Hello. I wanted to take the time to help you out with problems related to an object that's going up and then down in the air. Okay. These tend to be quite difficult for students. So let's get started. So this is your website, and if I go to Mr. Dana's family, and I scroll down, I got an example here of an object going up and down. um, let's see. Yeah, it's a video called Papa and Son Rocket Launch. All right, let's see what we got here. Yeah. Here's my son Tristan. You can hear all the people hanging out at Topanga Beach. Oh, there goes the rocket. Uh-oh, there it comes. Right.
Nice.
So let's see that again. This time I'll shut the volume off. And what we want is to try to figure out how long this thing was in the air. Okay? So I'm going to press pause when it looks like the rocket's in the air already. Should be pretty soon. Oh, it must be in the air. There it is. I missed it already. Okay, now let me go back. Okay. There's the rocket. Okay, it looks like at around 23 seconds. So at t equals 23 seconds, it's in the air. Still in the air. Okay. So 23 to 25 seconds. And by 30 seconds, oh, 29 seconds, 27 seconds. Okay. So it looks like there's the shadow from it landing. Let's see here. Okay. So it's a little hard to tell, but let's see what we can do here. So I'm going to estimate, because I'm not really sure from the video, but I'm going to say at about 23 seconds, rocket leaves launch pad. And then at about 29 seconds, the rocket hits the ground again. Okay? So if I take these times, I can find, I'll call this T1 and I'll call this T2. And we can say that our change in time is our T2 minus T1, which is 29 seconds minus 23 seconds, which looks like it's about 6 seconds. And this is the time rocket is in the air. Okay? And let's see here. I should draw a velocity time graph. Now, I'm going to make upwards negative direction, and I'm going to make down positive direction because I know that my acceleration due to gravity is down, so I like making down positive. You can make up positive as well. It doesn't really matter, but I prefer making down positive. And in any physics problem, you need to choose which direction is positive. Okay? So based on this assumption, I'm going to draw a velocity graph, and I'm also going to draw an acceleration time graph below that. Okay? So this is a nice little stack of graphs, that's what we call it. Okay? There you go. And acceleration time, velocity time. Velocity is in meters per second. Time is in seconds. Okay. Acceleration is in meters per second squared. And any object, while it's in the air, if down is positive, then my acceleration is positive. That was the whole reason why I made down positive. Okay? And I know my rocket is in the air for 6 seconds. So I'm going to write 6 here. And I know that the area under my acceleration time graph is going to be 10 meters per second squared times 6 seconds. Well, the units for that are going to be 60 meters per second, and that's going to be my change in velocity. Okay? And I should probably try to draw my velocity graph now. If down is positive, my rocket starts with a negative velocity, and it should, as the rocket goes higher, this negative velocity, these numbers become smaller and smaller until my velocity is 0. That's the rocket at its highest position. So my initial velocity is a negative number. Then the rocket at this moment in time is going to have 0 velocity and be at its highest position. And then the rocket's going to speed up as it moves downward. And our velocities will become bigger numbers, and these numbers will be positive because the rocket's moving down. And it looks like this whole thing takes 6 seconds. Okay, so I'm going to label this 6 seconds. And if it takes 6 seconds to go up and come down, the 3-second moment in time should be my highest position. Okay, and let's see what else we can find out here. My final velocity at 6 seconds would be here, okay? And it looks like my change in velocity for the entire trip up and down, so this is my change in velocity for entire trip up and down is going to be 60 meters per second. So that means from my initial velocity to my final velocity, if I subtracted my final velocity minus my initial velocity, I would get 60 meters per second there. Okay, so the only way that's going to happen is if this is negative 30 and this is a positive 30. So I'm using the symmetry of my graph to sort of figure out my numbers. Okay, and this area here, try to figure out what that is now that we know the dimensions of the triangle. So on the trip up, for the first 3 seconds, I'm talking about negative 30 meters per second times 3 seconds. And I don't want the rectangle here, I want that triangle. So I'm going to have to divide that by 2. And I'm going to get 15 times 3, which is a negative 45 meters. And this is the change in position on the trip upwards. Okay?
All right, and we should have the same exact change in position on the trip downwards, except instead of it being a negative value, this is going to be a positive 45 meters because our displacement, our total displacement, our total change in position, which is called displacement, is 0. Since the position of the rocket when it's launched is the same position as where it lands. Okay, so position of rocket at the end is the same as the position of the rocket at the beginning. Okay, and we found the velocity of the rocket, the final velocity of the rocket at 6 seconds, just before impact on the ground, right? Notice it's positive and downward is positive. And we also have, see here, I'll draw an arrow over here. We also have an initial velocity of the rocket. Whoops. There you go. Initial velocity of the rocket when it is launched. And that's a negative value because the up direction is negative. Anyway, that's about it. That's about all I could figure out right now. Pretty cool. You notice we figured out how high the rocket goes. Looks like it's going about 45 meters. And we figured out how fast it's going before it hits the ground and when it's launched. Pretty cool. Pretty classic problem and pretty cool. Hope you enjoyed it. Have a good day.